Hello, math students. Mr. B here with a quick review of working with numbers with signs, negative signs, positive signs on your numbers. So let's start by just looking at the number line because that'll define what a positive and negative number is. So I've got 0 right here in kind of the middle of my figure. To the right of the 0, those are numbers that are positive. And you probably know a lot of this already. This is a review, right? All right, so numbers to the right of 0 are positive numbers. They're greater than 0. To the left of the 0, those are the negative numbers, numbers that are less than 0. All right, there are negative numbers all over the place, right? All over the physical world. Let's see if we can just think of a few cases here to give you an example. Temperature, right? If you live in a cold climate like St. Paul, Minnesota in the winter, you know that you could have below 0, right? Temperatures below 0. Those would be like negative temperatures, right? Negative 20. And above 0, right, for positive. Above 0. How about altitude? Most altitudes are based on sea level, right? So you have above sea level, those would be numbers that are positive, altitudes that are positive, and then you could have negative altitudes, which are below sea level. So below sea level. My pen's not working good here. Sea level. How about electrical charge? For those of you who are into physics and things like that, you can have a positive charge. A particle might have a negative charge, like an electron is a negative charged particle. So we have positive, I'll just write positive and negative charge. And velocity. Positive would be where you're going forward. Negative would be going backwards, velocity. Like speed, but the direction's involved. So backwards. Usually we think of speed as always being positive, but velocity can be negative. All right. You should think of a number as having two properties. One is the magnitude. And on a number line, we think of the magnitude as being the distance from the number on the number line to the 0 on the number line, where distance is always positive. So the magnitude is the distance from a point on a number line to 0. We sometimes use absolute value symbols. You might remember those as those straight bars. I'll have an example in a second of this. And then the sign. So a number has two properties. It has a magnitude and then it has a sign. And the sign is either positive or negative. All right, so let's say we have the number 4. What's the magnitude of 4? Well, we take the absolute value and we always get a positive, so we actually get the same number, positive 4. So the magnitude is 4. And the sign, we don't see any negative sign, so this is a positive number. The sign is positive. All right. How about negative 6? The magnitude of negative 6 is the absolute value of negative 6. We said the result is always positive, so it's 6. I said that the magnitude was the distance from 0 on the number line. I didn't really show that in the previous example. Let's say 1, 2, 3, 4. Here's 4. Here's 4 on the number line. And you can see that the distance from 4 to 0 is 4 units, say. And in this problem, the next problem where we're looking at negative 6, maybe here's 0, 1, 2, 3, 4, 5, 6. Here's negative 6. And how far is that from 0? Well, it's 6 units. So the magnitude is 6. And what's the sign? The sign here is negative. All right, let's move on. We would like to next do operations on the numbers. All that means is we're going to add, subtract, multiply, or divide. Something like that, right? Those are the operators. We want to know what's the sign of the result and how is that related to the signs of the numbers that you're operating on, that you start with, okay? The easiest case is multiplying and dividing. The end result only depends on the signs of the numbers that you're multiplying or dividing, not on their magnitude. So let's go over this. It's very cut and dry. There's only one answer you could get. If both numbers are positive, the result is positive. If both numbers are negative, the result is positive. It's only when one number is negative and one is positive, so a positive and a negative, that the end result is negative. All right? So those are the simple rules. There's 3 rules there. Here's some examples. 3 times 4. They're both positive, so the answer is positive. We're going to get 12. Positive 12. Negative 3 times negative 4. Well, they're both negative. We should have those rules. Can you sort of see the rules right there? Yeah. If both are negative, the result is positive. So we're going to get positive 12 again. Hey, what's going on with my pen here? I'll chalk it up to the technology. Anyway, okay, now we have a negative number times a positive number. So they're opposite signs. The result should be negative. Notice I'm multiplying the numbers, like sort of forgetting the sign, and giving the end result, the sign of the end result based on the table. Okay, so 3 times 4 is 12, but one is negative and one is positive, so the result is negative. Let's do these division ones. Well, let's finish up the multiplication. Okay, so the last one here, again, is a positive and a negative, so we're going to get a negative result. Division, same idea. Divide two positives, we're going to get a positive. 10 divided by 2 is 5. Negative 10 divided by negative 2, both are negative, result is positive. And then these last 2 cases is mixed, right? We have a negative and we have a positive in both of them. So the end result is going to be negative. We still get 5, but the result is negative. If there's more than 2 numbers in a string of multiplication and division, what do? Well, it's easy. You just go left to right, 2 numbers at a time. So let's do this example and see what happens. We've got 2 times negative 6. We're starting from the left, right? 2 numbers. One's positive, one's negative, so the result's going to be negative. 2 times 6 is 12, so negative 12. And now I'll just copy what we have above. I'm just copying. And now we're going to do the next 2 numbers. Negative 12 divided by positive 3. It's a negative and a positive, so the result's going to be negative. 12 divided by 3 is 4. Times 8. I'm copying what's above now. Now we do the next 2 numbers. Negative 4 times 8. Well, again, it's a negative and a positive, so the result's going to be negative, and the number is 32, right? So negative 32. And then we're dividing by negative 2. We're down to the last 2 numbers now. I should be putting little equal signs on each line to show that they're equal to the line above. All right, so what's negative 32 divided by negative 2? 2 negatives, that's positive, right? So 32 divided by 2 is 16. We said the result is positive because we're dividing 2 negatives. That's the result, positive 16. There's a trick for getting the signs for strings of multiplication and division. Only for strings. If there's pluses and minuses in there, all bets are off. But if it's just a string of nothing but multiplication and division, you can actually count up the number of negatives. If you have an even number of negatives, the result is positive. And if you have an odd number of negatives, the result will be negative. What about that previous example there? How many negatives were there? 1, 2. There were 2. That's even. And look, the end result was positive. Okay? Okay, let's move on. The next bit is a little harder to do. This is where we're going to be adding numbers with signs. Okay? The reason that adding is trickier is if one number is positive and one number is negative, the end result's going to depend on the magnitude and the sign of the numbers being added. Let's do the easier case, though, where they're both positive or they're both negative. If both numbers are positive, the end result's going to be positive. And if both numbers are negative, the result's going to be negative. Okay? So the rules are a little different than the multiplication and division, right? With multiplication and division, when they're both negative, you get a positive. But when you're adding, if they're both negative, the result's negative. So here's some examples. 3 plus 4, right? They're both positive. You're going to get positive 7. If they're both negative, you're still going to get 7, but the sign is negative because they're both negative. It'd be like saying you've got 3 electrons plus 4 more electrons, right? Those are those negatively charged particles. Then you'd have 7 electrons, which would be negative 7 in charge, right? Mathematicians might say what we're doing here is we're adding the magnitudes and giving the result the sign of the original numbers. So in this one with the negatives, the magnitude is 3 plus 4. So to forget the signs, right? Throw away the signs when you're adding the magnitudes. That's what gave us 7. And then the end result is the sign of the original numbers. Okay, let's move on to the harder case. What if we add 2 numbers with opposite signs? What do? I like students to think of a tug of war. Do you know what that is, right? You've maybe even done this, right? You've got opposing teams and they're pulling on a rope. And who's going to win here? So if we've got like negative 3 plus 5, I like to think of that as having 3 people on the negative team and 5 people on the positive team pulling. And they're all equal people. You know, it's not like you've got a big burly person and a small person on the other side. They're all even. And anyway, who's going to win here? Right? The positive team's going to win. By how much, though? It's like the positive team has 2 more pullers, right, than the negative team. So they're going to win by 2. They're going to win by 2. So we're going to say the positive team wins by 2. Well, I'll just say, first of all, the positive team wins, and they win by 2. They have 2 more people, right? So 2 more people. Than negative team. So 2 more people on the positive team than the negative team. So what's the end result here? I guess we should write with negative 3 plus 5 equals 2. Another way to think about it is with the charges, right? So if -3 plus 5 means that we have 3 negative charges and 5 positive charges, I'm writing them down here so you can kind of visualize what's going on. Each pair of positives and negatives kind of balance each other out. But then there's 2 extra positive charges here. So the end result is 2 positive charges. Those are the extras here. Everything else balances out. Another way to think about it, this is sort of a classic way to think about it. You got a bank account with maybe the balance is 0. And you deposit $5 and you withdraw $3. What's the account balance? Well, the account balance is going to be $2, right? Okay. Let's move on to another example. Let's say we have -6 plus 2. Let's go back to the tug of war example. So team negative, they've got 6 people pulling to the left. Team positive, they only have 2 people pulling to the right. Who's going to win? Who's going to win and by how much? Right? Team negative is going to win. They have a lot more people. How many more people? How many extra people does team negative have? Well, they have 4. They have 4 extra people. So team negative wins. They have 4 extra people. They have 4 extra people. All right, so what's the end result? I'll write it down on the bottom here. Say -6 plus 2 is going to equal -4. Because negative's winning by 4 extra people. How about the charges? Using the charge particle idea, right? So here we've got -6 means 6 negatives. And 2 would be 2 positive charges. Look at what's paired up here. We get 2, right? We have 2 positives, and each would pair up with some of the negatives, and that leaves 4 negatives without any positives to balance them out. So there's -4 for charge. And how about the bank account idea? Here's where you start with 0 in your bank account. You put in 4, but then you withdraw 6. And then your bank's going to be mad at you because you've borrowed money, basically. So the account balance would be -$4, right? -$4. All right. So I hope you get an idea what's going on when you have a positive and a negative number adding. You have to decide who has the bigger magnitude, right? If you took the absolute value of the numbers, you'd see which number has a bigger magnitude. Like in the case with -6 plus 2. -6, the magnitude of that number is 6. The magnitude of 2 is 2. The negative number had a bigger magnitude. Negative wins. So that's a way of like thinking about it without having the drawing with the tug of war, you know. The general result here of adding numbers with different signs. We compare the magnitudes of the numbers. The sign of the number with the bigger magnitude wins. The magnitude of the result is the difference in the magnitude of the numbers. So remember when we had, 5 plus -3. The difference is 5 minus 3. We just look at the numbers without the signs. The bigger number, well, the 5 minus the 3 gave 2. And then the 6 and the, 6 and 2? -6 and 2. We subtracted 6 minus 2 and we got 4. I've got an example right here. So -6 plus 2. Compare their magnitudes. So I'm comparing the absolute values. You don't have to do this. I'm just showing it because mathematically this is how you describe comparing the magnitudes. So we see that the magnitude of the -6 is bigger than the magnitude of the 2. And the -6, well, it's negative. The negative wins because its magnitude was bigger. So we know the end result's going to be negative. How do you get the magnitude of the result? Well, you subtract the magnitudes. Forget the signs, you go 6 minus 2, you get the 4. The end result is negative 4. If none of this makes sense, think about the tug of war, or think about the charges idea, or think about the bank account idea. Whatever you do, come up with a way where you get the right answer every time. All right, I know this is a long video. I thought it would be 15 minutes. It's pushing 20. But let's keep going. We've got one more issue here. And I can hear my furnace turning on, so it's going to, I hope, not mess up the sound too much here. But anyway, what do you do when you're subtracting numbers with signs? Well, it's easy. You convert the subtraction to addition using this formula. So if you have a minus b, that's the same as a plus the opposite of b, or negative b. A plus negative b. Then, now that it's addition, you use the addition rules. Let's see an example here. Let's say you've got 4 minus 6. You could write this as 4 plus negative 6. So who's the winner? Which one has the bigger? Now it's addition, and we're going to compare the magnitudes, right? Which number has a bigger magnitude? Well, the negative 6 has a bigger magnitude. 6 is bigger than 4. And it was negative, so negative's going to win. How do you get the magnitude of the result? Well, you subtract the number. 6 minus 4 is 2. So that's the answer there. All right, this one. 4 minus negative 6. Well, the rule up here says we've got to add the opposite of the thing we were subtracting, and that thing was negative 6. So we get 2 negatives. That's kind of weird. But what's the opposite of a negative? That's positive. 4 plus 6. So the answer here is just plain 10. We're adding 2 positive numbers. It's kind of interesting, right? Subtracting a negative is the same as adding a positive number. Something to remember. Okay, how about this case? Negative 4 minus 6. This would be negative 4 plus negative 6. Now we're adding 2 negative numbers. The end result is going to be negative, and we just add the magnitudes. 4 plus 6 is 10. So the answer is negative 10. I didn't box in this one. All right. One last one here. Negative 4 minus negative 6 will be negative 4 plus the opposite of the negative 6. So again, how did this go? Subtracting a negative is like adding a positive. The opposite of negative 6 is positive 6. Okay, who's going to win now? Who's the winner? If we compare the magnitudes, the 6 has a bigger magnitude. It was positive. The end result's going to be positive. The size of the magnitude of the resulting number should be the subtraction, right? 6 minus 4 give you 2. So let's just talk about that bit about subtracting a negative is the same as adding a positive. If we drop that double negative notation, and you see this, 7 minus negative 9, a lot of people just go, oh, put a plus on each of them. 7 plus 9, result 16. Easy, right? Instead of writing, what do I mean by the double negative? I mean this here, where we get 2 negatives. So instead of writing it as like this, I'm just going plus and plus for that case. A lot of people, when they get to like a problem like this, they might go plus and then write a little negative on there. It's just a notational thing to get quickly to what you have to do. Okay, this one, this would be negative 5 plus 2, right? Subtracting a negative is like adding a positive. Well, one last thing I think is just to summarize what's going on here. If we multiply or divide numbers with signs, here's the results. Both numbers positive, the result's positive. Down at the bottom here, both numbers negative, the result's positive. Both numbers negative, result is positive, whether you're multiplying or dividing. But the mixed case where you're multiplying a positive and a negative, or dividing a positive and a negative, the result is negative. If you're adding, then it's complicated, or more complicated. The easiest bit of the adding is when they're both positive, the result's positive. If they're both negative, the result's negative. So you add the magnitudes, and the sign is the same as the numbers you're adding. Okay, what if the numbers are opposite sign and you're adding them? Well, the sign of the number with the bigger magnitude is going to be the sign of the result. You subtract the magnitudes to get the magnitude of the result. Think of the tug of war for that case, right? And if you're subtracting, convert it to addition and then use the addition rules. All right, I hope this review was good and is helpful. Dealing with negatives is always a struggle, but if you do it right, that'll make other things you do in algebra a lot easier. So we'll see you soon. Bye now.